Hello friends, this is AKHILESH Pandery, and in this lecture I am going to start the network analysis lecture number 6. And in the last class we had discussed KCL and KVL, and in this class I am going to apply those equations or those laws into the two famous analysis, and that is mesh analysis and nodal analysis. So here the first I am going to start with mesh analysis. And before understanding the mesh analysis, we must understand first the meaning of mesh. Mesh actually is the loop that having no inner loop. Okay, so if any loop is there inside which there is no any other loop, then that loop will be called the mesh. So here I am taking an example for that, and it is like this. So if I am considering this loop, then this will be considered as a mesh because it has no any inside loop, no any inner loop. But if we will try to consider this loop, then inside that loop there is another loop. Okay, so it means this will be not considered as mesh, but this is considered as mesh. So it is clear that mesh is a loop that is having no any inner loop. This is again a mesh, but overall this is not a mesh. Then what it is called? So this one will be called the super mesh. And we will learn some super mesh technique when this type of mesh is useful. But before, we will first understand that this is a mesh and we are going to start the mesh analysis. Okay. One more definition that we must know is planar network. This is a terminology. Actually, the planar network, by the name itself, it is clear that any network which is drawn in a single plane will be called the planar network. For example, this one I am taking. So the entire circuit has been drawn in a single plane. There is no any other plane apart from it. Means on the single plane the entire network elements has been drawn. So it will be called as planar network. Now if I am drawing a circuit like this, and we have resistance values like this. So here we can see that some element and some connection, some branch is overlapping. So it is not a planar network and this is a planar network. So this will be called the planar and this will be called as non-planar. So overall we can discriminate between a planar network and a non-planar network. Now, what is the reason that I have introduced this planar network here? So, a mesh analysis can be applied to only the planar network. It cannot be applied to the non-planar network. So, if there is a non-planar network, then we will try to make it first planar, and then after we can apply the mesh analysis. Otherwise, then on the non-planar network, the mesh analysis is not applicable. So now we will. This is all the brief before understanding the mesh analysis. Now we will start the mesh analysis. So the steps that are involved in the mesh analysis are as. So let us find the steps first. So here we have the steps. So the first step that we have, we have to analyze all the mesh. Analyze all the mesh. Means if we have a circuit like this, I am taking the circuit like this. Okay. Overall circuit like this. So this is B, some voltage source, this is resistance, some resistance R1, R2, this is R3 and this is R4. Now, first of all, the first step in mesh analysis is to analyze all the mesh. So here we have one mesh. The mesh is that which has no inner loop. So here in this loop there is no any inner loop, so this will be the first mesh. Now again we have the loop that has no any inner loop, so second mesh. And if I am considering this loop, then this will be not considered as mesh, because inside this entire loop there is one inner loop again and second inner loop again. So overall this will not be considered. So we got the two mesh, we have analyzed the two mesh. Now the second step involved is to assign current to each mesh. So on each of the mesh we have to assign some current. So in this mesh we will assign some current I1. Again on this mesh we will assign some current I2 in this way and in this way. Okay. So the second step is over, first step is over, second step is over. Now in the third step what we will do? In the third step we have to write KVL for each mesh. KVL equation, you can say KVL equation for each mesh. So we have the two meshes, this one and this one. So for the both of the meshes we will write some KVL equation. So for this mesh first we will try to write. So before writing the KVL equation we must know the Ohm's law. Means the Ohm's law is defined as the voltage drop across any resistance is given by this equation, V equals to IR. So for this resistance means R1, if we consider that the voltage drop is V1, then overall this I1 current only flowing through this resistance R1. So V1 will be equals to I1 R1. So V1 will be equals to I1 R1. Similarly, we will try to determine the V2. As per the Ohm's law, again V2 we can determine very easily. Means I1 is going this way and I2 is going in the upward direction. So overall I1 minus I2 will be in this direction and there will be a voltage drop. I1 minus I2 will be in this direction. Means in this branch downward we will have overall I1 minus I2 current. Okay. So V2 we can write very easily I1 minus I2 into R2. And similarly we will try to find the voltage drop across R3. V3 is this. V3 equals to this I2 is only flowing through this R3. So V3 equals to I2 into R3. Again we can find the V4 through it across the resistance R4. So V4 again I2 is only flowing through it. So I2 into R4. So overall we have got all the voltage drop across the resistance R1, R2, R3 and R4. So now we have to apply the KVL equation for this mesh. So from the KVL we know that summation of all the voltages across this loop will be 0, and we have to just check the polarity. Means we have to consider the polarity for the summation. So if I am taking the exiting polarity, then in the entire loop, if I am rotating in this way, then in the entire loop we will have to take the exiting polarity only. So here I am exiting from the positive polarity, so I am taking as plus V. Next exiting from negative polarity, so considering as minus V1. Next from minus V2. Next nothing, reached the same place, so over means equals to 0. Now we will put the values of V1 and V2. Simple Ohm's law that we have to find, we have just found out. So V minus V1 means I1 R1, minus V2 means I1 minus I2 R2 equals to 0. So this is over. Again we will try to find out the KVL in this loop, in this mesh. So again exiting 1 plus V2 minus V3, exiting polarity minus again, so minus V4 equals to 0. Now I'll put the values of all these V2, V3, V4. V2 we have got I1 minus I2 R2, I1 minus I2 into R2, and minus V3. V3 we have got I2 R3 and minus V4. So I2 R4 is equals to 0. So this is the second equation, this is the first equation. In any given question, we will have the values of voltage source, we will have the values of resistance. So we will put the value of V, R1, R2, R2, R3, R4. Overall, we will have two unknowns, I1 and I2. So using the two equations, we can find easily the values of two. Means the last step in this will be to find I1, I2 using the KVL equations. So the KVL equation we have just got, and using those equations we will find the I1 and I2, and later we can find any branch voltage, means any voltage across any element. Okay, so this is the step involved in the mesh analysis. First we have to analyze the mesh. All the mesh, means here we have the two mesh, means the mesh inside which there is no any inner loop, so these are the mesh. Next we have to assign the current to each mesh, so we have assigned here I1, here I2. Next we have to write the KVL equation for each mesh. So for this mesh we have written the KVL equation in this way, and we will use some Ohm's law for finding out the voltage drop across each resistance. And next, the final step is to find the unknowns, of course the current unknown, using the two KVL equations. So this is all about the mesh analysis. Now there will be some case where the KVL equation cannot be written for some given circuit. So let's check out those type of circuit in which we cannot apply the mesh analysis. So here it is. If we have a circuit like this, if we have a circuit like this, okay, so here is some voltage, here is some current. Okay, so if we try to apply the mesh analysis in this given network, then what we will have to do, we have two mesh and we will put I1, here we will put I2. So while writing the KVL equation for this mesh, I am writing V. If this is R, we will write minus I1 into R. Now after that we will have to find the voltage drop across it. So that voltage drop is unknown, because across the current source we cannot find the voltage, means voltage drop across the current source. So in this case we cannot apply the KVL, and that's why the mesh analysis fails here. Now what we can do then we can use the super mesh technique. What we can do, we can do the super mesh technique to solve this equation, this type of network. Super mesh technique means instead of taking the mesh, means the loop which having no any inner loop, we will take a super mesh which is having the inner loop. So this type of super mesh we will consider, and also we will apply some KCL to it, because if this is I, so we can assign some current to the entire super mesh, means we can assign some I1 current to entire super mesh. So I1 and I means I1 is coming from here and I is going in this branch, I is flowing in this branch. So remaining I1 minus I will be flowing in this branch. So in this way we can write the super mesh equation very easily. V minus I1 minus I current is going in that one. So I minus I1 into R1 resistance value, means there will be the drop like this V1. That V1 will be equals to I1 minus I into R1. Now next this will be the voltage drop here V2, and that V2 will be equals to, again this I1 is flowing through this branch. So that V2 will be equals to means minus I1 into R2. And again if this is R3, then that V3 will be minus I1 into R3 and equals to 0. So overall we have applied the KVL to this super mesh. So instead of mesh, we have applied the KVL to the super mesh. So for this type of network where there is a current source in the common branches of two mesh, then in that case mesh analysis fails, and instead of mesh analysis we apply the super mesh technique. So this was the special case. Now I am taking one example from the previous GATE exam related to the mesh analysis.